Hi everyone and welcome to this tutorial session. In the question we have today, we have 8x raised to the power 6 plus 7x cubed is equal to 1 to solve for x. This is actually a polynomial equation, a polynomial of degree 6. A polynomial equation of degree 6 is supposed to have 6 solutions, so we should take note. Okay, so we're going to present a straightforward, easy to comprehend solution. So you are advised to watch the solution from the beginning to the end. Let's start. 8x to the power 6 plus 7x cubed equals 1 to solve for x. Let's move the 1 from the right hand side to the left hand side. We have 8x to the power 6 plus 7x cubed. Positive 1, bringing it this way, becomes negative 1. So that we have 0. Now this is a complete polynomial equation of degree 6. Now, at first sight, it could look very intimidating. But with little mathematics tricks, we'll be able to reduce this polynomial equation of degree 6 to a mere quadratic equation, which will be a lot easier to solve and handle. How is that done? We look at the power 6. Power 6 can be written as power 3 multiplied by 2. So this can be written as 8x cubed to the power 2 plus 7x cubed minus 1 equals 0. So we now see that we have actually reduced that polynomial equation of degree 6 to a quadratic. This time it's a quadratic in terms of x cubed. Now let's make it better by doing the substitution w equals x cubed. Now everywhere we see x cubed, we're going to write w. So the transformation gives us 8w squared plus 7w minus 1 equals 0. This is what we get now. So the quadratic is a lot better here. We can easily solve this quadratic equation. Now let's collect our coefficients. The squared coefficient is a, and the squared, w squared, the coefficient is 8. B is the coefficient of w, and c is our constant. Now we should always make sure that we collect this information accurately. Any mistake here will lead to wrong solution. And so we are going to apply now the quadratic formula in terms of the variable w. Okay, so writing the quadratic formula in terms of w, we'll have w is equal to minus b plus or minus the root of b squared minus 4ac. All of that divided by 2a. Now let's put in the values of a, b, and c carefully. It's negative 7 plus minus the root of 7 squared minus 4 into a into c. All of that divided by 2a. Let's work out this. Negative 7 plus or minus the root of 7 squared is 49. Negative multiplied to negative, positive. So plus 4 times 8 is 32. All of that divided by 16. And so we have w is equal to negative 7 plus or minus 49 plus 32 is 81 all over 16. So we have w1 to be equal to negative 7 plus root 81 is 9 all over 16. This is just negative 7 plus 9 is 2 all over 16, which is 1 all over 8. And W2 is negative 7 minus 9 all over 16. This gives us, well, let's write it up this way. It's looking messy a bit here. So W2 is negative 7 minus 9 all over 16, which is negative 16 all over 16. That is negative 1. So we found two solutions for our quadratic equation. Our quadratic equation in terms of W. Now, this is not the end of the solution. We were asked to solve for x and not W. Look at our equation in terms of x. So how do we bring in the x? How do we solve for the x? We go back to our relation between x and W. Our relation says that W is x cubed. Okay, so let's put x cubed in the place of W now in W1 and W2. So when we take W1, we found it to be 1 all over 8, which is the same as 1 all over 2 cube, which can be written simply as a half cube. A half cube. Now, let's replace W with x cube. So this means that x cube will be equal to a half cube. This is a cubic equation. We should not make the temptation again at this level to say that since the powers are equal, it therefore means x is a half. That will give you just one. We're supposed to have three solutions here. Remember, our original equation is polynomial of degree 6. We're supposed to have 6 solutions. This one is going to give us 3 solutions. Okay, so let's proceed by taking this half to the power 3 to the left hand side. So we have x cubed minus half to the power 3 is equal to 0. This now again is a difference of cubes expression. So we apply the difference of cubes identity. We're going to obtain, when we apply the difference of cubes identity, we're going to obtain x minus half into x squared plus x times half is x all over 2. Half squared is 1/4. Okay, so applying the difference of cubes identity, we obtain this expression. Okay, we obtain this expression. So now let's continue to solve for x. So if this is true, it means either this first part is 0 or this other expression is 0. So we say x minus half is 0. X minus half is 0. Okay, we have the x minus half is 0. If that is true, it simply means that x is equal to half. So we found the first solution to our polynomial equation of degree 6. X equals half is our first solution. Or we take now the other expression, this one, we equate it to 0 also and solve. And it is a quadratic, so it's going to give us the remaining two solution of this first part. So, or x squared plus x all over 2 plus 1/4 is equal to 0. Okay. Now this is a quadratic equation, so it's going to give us the other two solutions. So let's collect our coefficients. A is 1, B is a half, and C is 1/4. So x equals minus b plus minus the root of b squared minus 4ac all over 2a. So x equals, let's put in the values of a, b, c carefully. Negative half plus minus the root of half squared minus 4 into a times c. Okay, let's write this one very well. It's a bit out of focus. So we have is equal to minus half plus minus the root of b squared is half squared minus 4ac. Now this gives us all over 2. This gives us minus half plus minus the root of half squared is 1/4. This 4 here cancels with the other 4. You have 1/4 minus 1. All of that divided by 2. Now, we continue this way. We're going to have x is equal to minus half plus minus the root of a quarter minus 1 is negative 3/4 all over 2. Now, root of negative 3/4, root of negative numbers do not exist in the field of real numbers. So we're going to have complex roots there. And so root of negative 3/4 will simply be root of negative 3 all over root of 4. And root of negative 3 is root 3i. So that's going to give us root 3i all over 2. Root 4 is 2. So here we're going to write root 3i all over 2. Okay. So that will give us negative half plus minus root 3i all over 2 divided by 2. So it's going to give us negative 1 all over 2 times 2 plus minus root 3i all over 2 times 2. So we have a common denominator of 4. So we're going to write them as write all of this as a single fraction. Negative 1 plus minus root 3i all over 4. Okay, so this gives us the two other solutions for our first part. Our first part. Okay. Now, the second value for our new variable was w equals negative 1. So let's handle a case where we have w equals negative 1. So we have here w when w equals -1. Remember, w again was x cubed. So x cubed equals -1. X cubed equals -1. We don't just go again to make the error to take cube root of both sides. If we take cube root of both sides, we're going to have x equals -1, which is just one of the solutions. We're supposed to have 3 solutions. This is another cubic equation. So to make it look very nice, let us take this -1 from the right hand side to the left hand side. It gives us x cubed plus 1 is equal to 0. Now, to make it look as sum of 2 cubes, 1 can be written as 1 cube. So it's the same as x cubed plus 1 cube is equal to 0. So we have here sum of cubes, and we know the identity of sum of cubes. A cubed plus b cubed is the same as a plus b into a squared minus ab plus b squared. Now let's use this identity to transform this left hand side. We'll transform this left hand side to this form. So wherever we see x, we put a. Wherever we see 1, we put b. So this left hand side will be transformed as x plus 1 into x squared minus x times 1 is x plus 1. 1 squared is 1 equal to 0. So x cubed plus 1 cube equals 0 is the same as x plus 1 into x squared minus x plus 1 equals 0. We have the product of two expressions giving us 0. This simply means either this one is 0. If that is true, it means x is -1. That is our first solution for this second case. Or this quadratic x squared minus x plus 1 is equal to 0. Now we have to solve this quadratic. So let's collect our coefficients. A is the coefficient of x squared. B is the coefficient of x term. And C is the constant. So we have our A, B, and C collected carefully. Now let's use the quadratic formula. Let's use the quadratic formula. By the quadratic formula, x equals minus b plus minus the root of b squared minus 4ac all over 2a. So let's put in the values of a, b, and c carefully. So x equals minus 1 plus minus the root of minus 1 squared minus 4ac all over 2a. This gives us minus minus positive 1 plus minus the root of -1 squared. -1 squared simply means we multiply -1 by itself. Negative times negative, positive. 1 times 1, 1. So we're going to put 1. 4 times 1 times 1 is 4. So we have minus 4 all over 2. This gives us 1 plus minus 1 minus 4 is -3. So we have x equals to 1 plus minus the root of -3 all over 2. Okay, so this gives us the other two values of x. So let's go ahead and write our answer in the most simplest of forms. So we are going to have we're going to have x equals 1 plus minus root negative 3 is just going to be root 3i all over 2. So the two values of x are 1 plus root 3i all over 2 and or x equals 1 minus root 3i all over 2. So we'll finally have all our 6 solutions. All our 6 solutions for the polynomial of degree 6 that we just had to solve over there.